Oh, that was nice. Do it again.
Riding on a big white butterfly, I turn my back away towards the sky. Close my eyes to look for something, so myself is really nothing. Then I realized my butterfly wasn't really up there with me. We all make mistakes, forgive me. Would you like to ride my butterfly? Riding on a long blue paper plane, getting seasick, sorry once again. Landing strip is getting near, hope the fog lifts, make it clear. Then I realized my paper plane wasn't really up there with me. We all make mistakes, forgive me. Would you like to ride my paper plane? Riding in a 3 grand Deutsche car, A to B is often very far. Home is near but such a long way, legs and heads all feel the wrong way. Then I realized my Deutsche car is only there to get me somewhere. Even so, I really do care. Would you like to ride my Deutsche car? Would you like to ride my paper plane? Would you like to ride my paper plane? Would you like to ride my paper plane? Would you like to ride my paper plane?
All right, so we're going to continue today with Java and probably finish up Java, but then transition into Java and object-oriented programming languages, or object-oriented programming paradigm. And we left it off last time with answering these questions of after we've loaded the book, we want to sort it by the title, right? And so we created a comparator to do that. That has this compare method that takes two books, A and B, and it gets their title and compares that title to B's title. And we can do that using compare to because it is built into the string class. We then wanted to know what the best books and the worst books were. So we made a comparator for ratings. And here we did a manual, if that rating is less than this rating, then that means they're out of order and we need to swap them, or the sorting algorithm will swap them because we want the best books at the top, the worst books at the bottom. Remember the general contract of this is that it'll return something negative if they're in order, positive if they're out of order, and 0 otherwise. And if you ever get mixed up, just go ahead and run it and see if it works, and oh no, I need to reverse that, okay? And then we sorted it, and we took the best book, which was the first book, and then the worst book, which was the last book. And this all still works here. There's Thud, and there's The Wanderer by Fritz Leiber. Right? So, what is the oldest book, and what is the newest book? I could copy-paste this up here, and instead of looking at the rating, I could look at the publication year. But what I'm going to do is I'm going to show you a better way of doing this using a more compact syntax. We're going to create a comparator for books by year, right? And then I'm going to call comparator.comparing. Now we need to tell it what to compare, okay? This will actually create a comparator for us that we don't have to write out all this logic up here. We can do it in one line. Now, the easy way of doing this is to say that the book class has this getter, this function over there called getPublication year. It's not called publication year. What is it called? Where's the year? Let's see. GetPublishYear. There. That's what we called it. So there it is. Right. Now this is brand new syntax. And in fact, it's relatively new to Java as well, and it's taken from, I believe, C++, and C++ took it from some other language. Basically, the comparator needs to know how to compare these two things. And so what I'm going to tell it is use that function over there in the book class. This is called a function selector operator. It's : the book class's getPublishYear. Okay? And now we can go ahead and call the sort method using that by year comparator instead. Let me go ahead and grab this and show you that it's actually working. Right? And expand this out. And here we go. Uncle Tom's Cabin, 1852. That's the oldest book in this particular collection. And then Sure, I'll Join Your Cult, published in 2023, is the newest book. Okay. So that was way easier. Did I have to write an if-else-if statement? Nope. That was way easier. What if we wanted to do something more complicated? What if we wanted to sort by author in descending order, but then by year in ascending order? Right? That's even more complicated because I've got tiebreakers. If I've got the same author, Frank L. Baum, who wrote wrote several more, but I've got 5 Wizard of Oz books in this collection in the CSV file. What I want is to see Frank L. Baum down at the bottom of the list, because I want all the Z authors up here and all the A, B, C authors down here in descending order. But then when I see Frank L. Baum's 5 books, I want to see them in temporal order. I want to see the oldest down to the newest. Right? We can use this same syntax here. I'll call it not by year, but by author, then year, right? Something like that. Comparator.comparing. Now the first thing that I want to compare is the author. So book, get author. Right? And let me see if that works. Is there no get author? There should be a get author. What was it called? Yeah, there's a get author, right? But it's not going to let me compile using this, because let me come over to the author, the person class, which is an author. Now, do you see any code here to say that that author comes before that author over here? Nope. So what we have to do is we have to write that code. Now that was already written for us with the string class. Let me show you where it is. Right? There's a string class that is comparable to other strings. If you gave me 2 strings, this string class automatically knows how to compare them, because there is this function in here called compare_to, right? That we've used before. And where is it? That's not it. That's not it. It's somewhere in here. There it is. And somebody already wrote the logic to compare 2 strings together. Okay? So what we need to do is we need to do the same thing, but not for strings, but for persons. So implements comparable person. Right, there we go. Now, that's going to complain because I have not actually implemented that function. I'll go ahead and generate the code to do so, and then there's a to-do to actually write the code, right? So what I'm going to do is I'm going to compare this person, right? This person to that person. I should have called it that. There we go. I need to compare this person to that person. Now, for our purposes, two people are the same if they have the same last name and first name, okay? That's going to be our criteria. Now, in real life, of course, you would want something more strong than that. If you're talking about students, you'd talk about an NUID. If you're talking about U.S. citizens or taxpayers, you'd be talking about Social Security numbers. If you were talking about something that was pulled from a database and the database generated this person code or this person ID, we would use that, right? Or you would use maybe a UUID, which is a universally unique identifier, right? A cryptographically generated one. But for our purposes, we're going to keep it simple, and we're going to have we're going to check their last names to see if their last names are the same. To do that, I would say this dot for last name. I'm going to compare that to that dot for last name, that person's last name. Now, one of three things is going to happen here. Either it's going to be negative. In other words, that person comes before this person comes before that person. It's going to be positive, they're out of order, or it's going to be 0. Now, if it's 0, what do I need to do? I need to look at the first name. So if, and I need to store this in a result, by the way, int result is equal to, if that result is 0, then they have the same they have the same last name. So we need to compare the first name. I'm going to grab this code again and change all last name instances to first name. First. There we go. And first. Right. Okay. Now that it could still be the case that they have the same last name and the same first name, in which case they're the same person. So I'm going to end up returning 0 in that case. Right. But otherwise, I check their last name, and if it's negative or positive, then this never actually gets executed. So Smith, comma Jane is going to come before Smith, comma Zoe, right, or something like that. Right? But otherwise, if they have the same last name, then we look at their first name and compare those. Now we come back over to book demo, and what is now magically compiling? Now authors are comparable because people are comparable because I wrote that code over in the person class, and I can go ahead and sort it by the author. Right? Let me use this now, but then let me print this out and see if it's actually working. Right? All right, so Harriet Beecher Stowe, then Baum, then Vance. Does that look like it's in order of authors? Or in the order that I want? Stowe, what's wrong? It's wrong, but it's not wrong in the way that I wanted. All right. So by author, comparing book.author, yeah, go ahead.
Is it because you're always returning 0?
Oh, was I? Duh. Yes. Thank you. I should have returned the result. And by the way, that was a common mistake, but it was cleared up by most people in Lab 2, where we gave you a function and we just had it as dummy code, return 0 just to get it to compile. But the key was that you actually needed to return the child tax credit or whatever it was. Right? So thank you. Yes. Now let's run it. It'll still be wrong, but it'll be wrong in the way that I expected. Right? There's Maria Bamford at the top, then Banks, then there's Baum, and then all the way about down at the bottom here we've got Vance, Jack Vance. Is that in the order that I wanted? Right? Is that in descending order? Nope. So we can go ahead and chain another thing, dot reversed. Right? So if that's not the order that you want, all you have to do is reverse it. Right? You don't have to write your own code to say, okay, I'll swap that if and else if condition there. Right? I'll just reverse it. And now I've got, let's see, Vance at the top and Maria Bamford down here at the bottom. But I still don't have all of the Frank L. Baums necessarily in order here. Looks like they are, but that's just a coincidence. Here. Wizard of Oz, 1, 2, 3, 4, and 5. That's probably just because in the CSV file, that was the original order. I want to ensure that, okay? So I'm going to add another thing here. Let me go ahead and go to the next line. comparing the book's author reversed, then comparing the book's, what was it, release year? Get, publish year. Right? So you see how I'm chaining these things together? I want to compare the book's author, but reversed. Then, if there's a tie there that it has the same author, then I'm going to compare the published year. And I don't want to reverse that one because I do want it in order of oldest to newest. Right? And once I've done that, now I've got exactly what I was looking for. Vance up there, and once again, all the Wizard of Oz books are in release order there. Right? There should be somebody else here that was not in order before. There we go. All the Haruki Murakami books are in order now. 82, 14, and 17. In fact, that's going to be our next goal. Right? Find a book by, I'm going to underline that as best as I can, a book by Haruki Murakami. Right? How would you go about doing this? Would you write a for loop? Something like this, where, all right, if B's author is equal to Haruki Murakami, somehow, then output B, right? Something like that, right? No, I don't like writing code, and you shouldn't like writing code either. You should like using built-in functions to try to find something, okay? So the first step here is that I need the author, right? Author is equal to new author, or sorry, person, Haruki Murakami. There we go. Right. So I've got the author here. Now, what would you do with the collection of books here? How? I mean, you could write your own loop and loop through it and find that particular author. But what's a better way of doing this? So those of you coming from 155E, what's the fastest, best sorting searching algorithm that you can use? Binary search. Did you no? Those coming from 155A, did you do binary search in 155A? Nope. All right, then let's do it really quick. Here's an array: 5, 8, 3, 4, 9, 0, and 2. Right? I want to find 0. What would you end up having to do? Start at the beginning. Is that it? Nope. Is that it? Nope. 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 And finally, yes. How many comparisons did you have to make to get there? 1, 2, 3, 4, 5, 6. Now what if I told you that it was instead sorted? Right? So let's repeat all those values. 0, 2, 3, 4, 5, 8, and 9. There we go. Now it's sorted. Now I get incredibly lucky here. If I'm searching for 0, I get lucky and I find the last one. So let me change the problem. Let me try to find 9. Before, I made 1, 2, 3, 4, 5 comparisons to get to 9. Here I would have to make 1, 2, 3, 4, 5, 6, 7 comparisons to get all the way to the end. Right? But it's sorted. What if instead I looked at the middle element here, 4? The thing that I'm searching for is 9. Do I need to pay attention to anything in the lower half of this array? Nope. Because if 9 exists, it's going to be in this half of the array. There's one comparison. Now I'm looking at this half of the array. Once again, look at the middle element, 8. Right? That's not it, 2 comparisons. But do I need to look at the lower half of that half of the array? Nope. Just go one more over there, and now I've made only 3 comparisons instead of 7 comparisons before. That's the idea behind binary search. We're not going to write binary search. Instead, we're going to use binary search. And there's a collections.binary search. You're going to search the collection of books. Right? I'll come back to this. Actually, I'll initially do author. I'm going to search a collection of books for the author using a comparator. Comparator for authors. Right? So I need to actually make that comparator. And to do that, I'm going to steal this code up here and get rid of the reversal and get rid of the year. Right? There. By author. Right? And now the line is short enough that I can go ahead and put it all in one line. There's my comparator for authors. It'll go through and try to find a book that matches this author right here. It's not compiling. Let me walk you through why. Books. What is books? It's a list of books. Oops, sorry. List of books. Okay? What is by author? It is a comparator for books. Apples to apples, oranges to oranges, books to books. This is what's called my key. That's the thing that I'm searching for in the haystack, the needle in the haystack. Is that a book, though? What is it? It's a person. Oranges to apples now. I can't search books using an author. What I need is a book key. Book, Murakami key, right, is equal to new book. And I'm just going to say what the author is, because if I already knew what the title was, right, then I'd be done. Why am I searching if I already have a Murakami book in my hand right now, right? Unfortunately, and well, actually, I can put this down there and see that that solves the problem on line 120. But unfortunately, I don't have a constructor that just takes an author. Well, if you don't have a constructor like that, what you can do is you can start filling in null values. I don't know what the title is, or I don't know what the ID is. I don't know what that is. I don't know what that is. Why write a bunch of nulls when you can just give yourself a new constructor? Remember that we already had a constructor here that took all of the data. We already had a constructor that took all of the data except for the date that it was read. What's to stop us from creating a book with just the author? Person author. Right. There we go. And this dot author is equal to author. And then to do, clean this up eventually. In other words, I want to follow the same strategy that I did before of calling this other general constructor up here by passing in, say, 0, null, the author, that's what I want, null, 0, etc. Right? For now, this is good enough right here because it solves my problem over here. I just want to create a book with just the author so that I can search a collection of books for that author. Okay? Now, what that does is it returns an index, right? And then I can get that book, Murakami book, is equal to books.get an element at that index, right? And then system.out, I hope this fails because we're doing something wrong, right? Murakami book, there, okay? And there we go, it failed. Right? I was trying to search for a book of -29. Right? So let's go back to that example that we just did of 0 to, I forget what the numbers were, 5, 8, 9, whatever it was. Right? What if that were not sorted? Would my binary search idea work? What if it was instead 9, 2, 5, 8, and what did I miss? 0. What if instead it was like this? And then I'm searching for the middle, I'm searching for 9 still, but I check the middle element 5, and then I go searching in the right half of the list. Right? What happened? It's not there because it was not sorted. This blank line here was left intentionally. What did we forget to do? We created our comparator, but did we sort it using that comparator? Nope. So collections.sort by author, books by author. And that problem now goes away. And we in fact have a Haruki Murakami book. The first one we found, Wild Sheep Chase, 1982. Okay? All right. I want to expand that out. I don't want to just find a book by Haruki Murakami. I want to find all books by Haruki Murakami. But I want to go even further. I don't want just all books by a author. I want all books by organized by author. Right? I want to, if I gave you an author, Murakami, or if I gave you an author, Baum, or Maria Bamford, right? I want all of their books. Right? And I want that to be able to answer that question for any author and for all authors. Right? Have we looked at a data structure that would make this really, really easy? So if I were given an author, which is a person, right, I want all of their books. So, I don't know, something like that, and then a list of their books. So what am I hinting at here? What kind of data structure? We've looked at just 3 data structures. A set, that doesn't seem right. List, I've got a list on the other side. But then what's the third data structure that's really, really cool? A map, right? I'm going to map persons to a list of books, right? Because that if I've got the author there, I've got the Haruki Murakami, I'm going to go ahead and map them to all of their books, an entire list of their books. So map of a person to a list of their books. This is an excellent use case for this kind of data structure. And I'll call it author to books, right? Equals new hash map, right? Okay? Now, initially that's empty. We don't have any books in there. We don't have any authors in there. We don't have any people in there. Let's outline how we're going to do this. For each book, right? I'll call it even B. For each book B, okay? Get the list of books, get the author, A, I'll call it, and then find the list of books. Actually, I'm not even going to say find because I'm going to get the list of books in author to books by author A. Right? Now, one of 2 things is going to happen here. All right? Did we do the zip code example when we looked at maps? I think so. Right? But we were trying to count up the number of times a zip code appeared. Right? If we didn't do that, we can do that as another example. But in any case, the first time you see that zip code, right, then you're not, or the first time that you see this book, this author, right, then the list of books is not going to be there. Right? So if this is the first time we've seen the book/author, what I need to do is I need to create a new list of books. Then, if this is the second time that we've seen it, we've already gotten the list of books here. So in either case, we either create it or we already have it, and I will add the book B to the list. And then also make sure it is put into the map. Okay? There's my outline. Okay? Now I'm going to go through this outline and replace each one of these. This is kind of pseudocode, fake code. I'm going to replace each one of these lines with actual code. So we know how to iterate over each book. We've done it now a dozen times here, right? For each book, I'm just going to steal that code up there, right? There we go. For each book B, right? Get the author A, B.getAuthor. And I can store that into a person, I'll call it author instead of A. It looks like I've already used it, so I'll go with A. Right? Get the list of books from this map by that author. So a list of books, authors, books, right, is equal to that map, oops, I meant to copy that, dot get that author. So there's the map finding it for me. Remember I said find the list, right? I immediately erased that because the map finds it for us. We don't have to worry about that. If this is the first time that we've seen this book or author, then the list does not exist. So what do we need to do? We need to check to see if this is the first time. What does a map return if this key is not in there? Do we remember? It returns nothing. What is the equivalent of nothing in Java? Null. So if author's books is null, then we need to create it. So let me move that down, right? Create a list of books. Author's books is equal to new array list of books. Okay? Then regardless, we either have it from up here and it's not null, or it was null and we create it down here. In either case, it's going to be here, author's books. And we simply just add B to it. Okay? Now we need to make sure that it's put back into the map. Author's books, we are going to put the author, A, mapping to their books, author's books. There it is. Okay? Now let's print this. So print the map. Right? So for person author in author books, I'm just interested in the key set. Right? So for each key, which is an author here, person, author, and I've already used author, so I need to use A instead, sorry, right? I will say system.out.println A, and then I will go through their list of books. To do that, I use the same code as up here. So for book B, in the collection, get all the books by that author. I will system.out.println. I'm actually going to add a tab in front of it so that it's all nicely indented over. And then I will output the book there. Right. Let me run this. It's almost what I want. We're still not there yet. But let's take a look. All right. Janelle Moan, I don't know how you pronounce that, but memory librarian. Robert Heinlein, there's their book. Frank L. Baum, Wizard of Oz #5. I only see one book. That's a problem, right? How many books were there by Frank L. Baum? 5, right? Well, his other book is, his other books are, well, there's one, right? And there's the Marvelous Land of Oz 2, right? And if you keep looking, we'll find all of the other books by Frank L. Baum. Right? So why are they all separated out into different keys? The answer is a little bit deeper than I want to go, but I'll show you how to fix it at least. What we're doing here is we're using what's called a hash map. A hash takes an object, an author, a person, a book, and simply maps it to a number, an integer basically. Right? Now, that's what this hash map is using to determine that the author is different and the book is different. Right? Unfortunately, over here, by default, every person is different, even if they have the same name. Yes, I know that we did this compare to method down here, but that's used by the sort method. That's used by binary search. That is not used by hash maps. Instead, what we need is 2 other functions. And again, I don't want to get into details on those functions yet, but generally what you should do, especially if you're ever going to use a hash-based data structure, a hash set or a hash map or pretty much anything, what you're going to want to do is you're going to want to generate a hash code and equals method. Right? By default, it will be based on every single part in your object. Hash code is what takes this object and converts it into an integer so that it can be used by that data structure. Equals will go through all of them, like it'll be equal if the first name is equal to that other first name, and if the last name is equal to that last name, right? So it'll generate that code for you. So why didn't I just immediately do that instead of compare to? Compare to is more broad. Compare to says it goes like this, or it's like this, or they're equal. Equal only gives me that third one, that they're equal or they're not equal. It doesn't tell me that A comes before B or B comes before A. So all 3 of these are needed in our demonstration here, right? Let's do it for the book too. And once again, don't bother writing code. Just go up to source, hash code and equals. It should be based on everything for now, right? And then generate it, and you see all that code has been generated. Let me go back to the demo and run it again to see if that solves the problem. Right? Oops, that's not what I want. I want the console. There we go. Now where's Frank L. Baum? There we go. Frank L. Baum, he has now what? 5 books in that list. Because there aren't 5 Frank L. Baums. There's 1 Frank L. Baum, and that other Frank L. Baum in that other book is equal to this Frank L. Baum over here. So it ends up consolidating those all together. All 3 Haruki Murakami books are together now, too. Right? Looks like we've got Harry Harrison right there as well. Right? All right. Questions on this? Because by doing this map here, I have basically been able to answer most of my questions. Right? By using comparators, I'm able to answer other questions. Right? So think about how to do that in your own, in the third exercise especially of your first assignment. What are you going to want to do? You're not going to want to do a book. What are you going to want to do? Hopefully you've looked at it. It's due on Friday. Right? You're going to want running data instead, a running data point. Then you've got a list of running data points, or a list of running data points, right, that you've ostensibly that you've loaded up from actually 2 files. Right? And then you can start sorting them in temporal order. You can start sorting them in with respect to elevation, right? And then you can start processing them that way, right? All right. No questions? All right, the code will be, the code's already up there, but it will be updated with what we've done today here later on. What I want to do is I want to take a step back and do a more simple exercise. Right? Here's a simple exercise. Right? So it involves a little bit of physics. If you don't know any physics, that's fine. Radioactive isotopes decay into other isotopes at a rate measured by half-life. Right? For example, if we have a radioactive isotope of strontium-90, which is one of the byproducts of nuclear fission, right? So like a nuclear explosion, it has a half-life of 28.79 years. If you started with 10 kilograms of strontium-90, then 28.79 years later, you'd actually have only 5 kilograms left, because the other 5 kilograms has decayed into its decay products of uridium and zirconium, right? And those are probably radioactive too. And this is why nuclear weapons are bad, because strontium-90, the main byproduct, is going to sit in the environment for 30 years until it's half that. Another 30 years until it gets down to 25%. Another 30 years until it gets down to like 12%, right? And what is a safe level? There is no safe level of radioactive isotopes, but it's certainly going to take hundreds of years for it to either dissipate or decay, right? So given an initial mass m of an isotope with a half-life h, we can determine how much of the isotope remains after y years using the following formula. Why 1/2 there? That's the half-life, right? If you raise 1/2 to the year divided by the half-life, then multiply that by the mass, that gets you, 1 year later, right? 1 year later, that gives you how much strontium-90 is there. 28.79 years later, then of course it's half as much, and you've got this, the exponent will end up being 1, and you've got 1/2 left. Right? After 2 years, it's only 9.52 kilograms left. Right? We're going to write a program that prompts the user, or we're actually going to read some command line arguments, for a mass, a half-life, as well as a number of years, and outputs the isotope remaining after y years. For the example above, your output should look something like the following. Right? Starting with 10 kilograms of isotope half-life, 28.79 years, after 2 years, you would have that much left. Actually, I'm going to go ahead and go a bit further. What I want to do is I want to know how many, what does it look like after year 1, after year 2, after year 3, ... until we get down to that half-life that we only have less than half remaining. Okay? So let's write a program to do this. I'm going to go ahead and create a class. And by the way, if you need a refresher on like day 1, we can go ahead and create a new project, project ... Java, right? There's a Java project. And I'll call this, I don't know, assignment 00. That's what you should be doing. Remember, do not enable that thing right there. You will have troubles later on, right? Make sure that there is no module.java file, right? Finish that up. Right? Here's assignment 01. This is not your assignment, by the way. But we will put things into the package as specified, unl.soc. Okay? Right? This is, by the way, this is something that should have been done like the first week, right? Where you're setting all this stuff up. Right? Here's a class. I'll call it what? Isotope demo. There we go. And I will want a main, public, static, void, main. You can auto-generate that, by the way. I just didn't click on the thing to auto-generate it. Args. There we go. Right. So step 1, read in the following. Say initial mass. What else do we want? Half-life. Right. And what else did we want? And the number of years. Actually, I don't want the number of years. Maybe a name, like a name, right? Isotope name. There we go. Okay. I want to read those 3. I'm just changing the exercise a little bit here, right? So we want to read these things in from CLAs, equals command line arguments, just like in your first assignment, in your first exercise. Remind me how we do that. Well, first of all, let's take care of these variables, first of all. Isotope name, what type should it be? I like string too, right? Okay. What about the initial mass? Okay, why not an integer? What's can I get 9.52 out of that? Nope. So double, right? You could have 2.5 kilograms or whatever, right? What about half-life? That's in years, right? Years. So I could do integers because years are kind of, there's 1 year, 2 year, 3 year. Right? But what's more general? What's 1 year and 6 months? That's 1.5, right? So let's allow them to have fractional years, right? Half-life in years. It'll just be understood that it's in years. We'll actually fix that and make that better later on, right? So I've got my 3 variables here. I need to now read them in as command line arguments. Before I do that, what should I have checked? Did I receive the correct number of command line arguments? Right? Check if there are 3 CLAs, right? And I can do that by asking args.length. That should be equal to 3. If it's not equal to 3, that's a problem. How should I deal with that problem? System.out.println, error, provide name, mass, half-life, or something like that. Okay? Better yet, instead of going to the standard output, I can go to the standard error, and it'll appear in green, or not green, but red because it's an error. Can I recover from that? Nope. So let's go ahead and system.exit on them, okay? With an error code of 1. Right? So that if I ran this right now, I didn't provide any command line arguments, error, right? And now it's in red. Nice. Right? Otherwise, how do I run with command line arguments again? That drop down, run configurations, arguments, strontium 90. I don't know if that's how you spell it, but let's go with it. Right? And it was 10 kilograms, right? 10 or 10.0. And its half-life was what, 28.79 years? Is that right? 28.79, right? Apply that and run it. Right? Didn't do anything else, of course, because we're still not there. How do I read in a string as a command line argument? Say like a file name in your third exercise. Well, it's already a string. arg sub 0. Right. Of course, you would convert that over to a file and open that file with a scanner for assignment 3, exercise 3. How do I convert a command line argument, a string, over into a double? Double dot, parse double of args of 1. Same thing for half-life, but it's args of 2. Right? Now I've got my arguments. So let's print it out. Just as it's a sanity check, right? System.out.println. Let's actually do f. Print f. Percent s has or percent f kilograms of percent s isotope with half-life percent 0.2f years, right? And we'll output what? Mass, or initial mass, isotope name, and half-life, right? Just to make sure that I was reading those in correctly from the command line. Zoom out, there we go. 10 kilograms of strontium-90 isotope with half-life 28.79 years, right? Sanity check passed. We are actually reading these in as command line arguments successfully. Now what I need to do is compute my output, right? So what I'm going to do is I'm going to decay the isotope by 1 year until ... half of the original remains, or half or less of the original remains. In other words, I want year 1, I should have 9.7 kilograms left. Year 2, I should have 9.5 kilograms left. Year 3, I should have that many kilograms left. After about 29 years, I will have less than 5 kilograms left. Okay? What kind of a control structure does this sound like? Do something until some other thing happens. Sounds like a loop to me. What kind of a loop do we want? For loop or a while loop? Why did you immediately go to a while loop? Do we know how many years it's going to take? Not, well, I mean, kind of with half-life, but not really. While the current mass is greater than or equal to the original initial mass, I will continue to decay it by 1 year. Okay? By the way, when you turn your stuff in, this is cruft. This should not be in there. It's perfectly fine to do that as outlines, right? But when you're done, make sure that you take them out like I just did. Otherwise, that's bad style points and points off, right? I'm going to leave them in because these are going to be posted to the notes later on and you might find them helpful or may not, right? But this is not what you should leave in your final code. I don't have current mass, so I need an initialization condition here. Double current mass is equal to what? The starting mass, which I called what? The initial mass, right? Decay it by 1 year using this formula right here. The new mass will be the old mass times 1/2 raised to y divided by h, right? So the new mass, double new mass, right, is equal to the old mass, the current mass, times 0.5 raised to the power of 1 year divided by the half-life. Right? Now, obviously, that's not going to work, right? Because can I raise something to a power like this? Pythoners, you'll probably want to do something like that. You still can't do that in Java. Right? What do we do instead? Pow. Math.pow. It'll raise 0.5. Come on, there we go. 0.5 to the power 1 divided by half-life. Be careful with things like that. Right? When you have an integer divided by another integer, you're going to have truncation. 1 divided by another 5 ends up not being 0.2, it ends up being 0. Do we have that problem here, though? Half-life is not an integer. We're good. If you want to be extra careful, go ahead and go 1.0. Right? Okay. So now that I've got the new mass, I'm going to update the current mass is equal to the new mass. Right? And let's go ahead and print that out. Where should I print it? At the top? Right here? Or should I print it in between? Or should I print it at the end? Remember, this is a while loop. It depends on how you want it to work out. Right? So let's go ahead and try it right here. System.out.println. We'll print out the year here. Let's do a header up here to understand what we're going to output. So year 1, 2, 3, 4, 5, etc. Right? And then the mass, right? And then end the line here. Oh, I don't need to end line. That's println. Right? There's the year, and here's the mass, 0.2f. So year and mass, or current mass. There we go. I don't have a year, so let's go ahead and create it. Int year. Where should I start it out? 1, okay. 2, 0. Let's go ahead and try it with 1 first, okay? And then, of course, I'm going to want to update that. Let's see. Year is equal to year plus 1. Right? However, Pythoners, what would you do? Plus 1 plus equals 1, right? However, C folks, what would you do even shorter? Plus plus, right? And let's see if that works. Wait, println. What are you complaining about? Oh, that's right. It should be F. There we go. All right. Didn't work, did it? Let's go with end line there because it's not looking pretty. But there we go. Right. So what happened there? While the current mass, 10, is greater than or equal to the current mass, initial mass, which is 10, what should we have been doing with this instead? How long do you want to go? Until half of it is gone, right? So, yeah, the initial mass, half of that mass. Right? That'll at least get us somewhere. Okay, need to end line there as well. Right, there we go. So that gets us something. In year 1, your mass is 10. In other words, before it's decayed at all. Okay, fine. In year 2, you've gone down to 9.76 mass, right? In year 3, after 2 years, so in year 3 or after 2 years, it really depends on how you look at it, then you have 9.5. Is that correct? 9.5298. What do we have here though? 3. What is it doing? It's just rounding, right? And then finally, what at the last here, is the last year there where we have less? I don't like that. So what if we changed where we printed something? What if we moved it down here instead? Actually, let's move it here instead. Let's see if that gets us where we want. So at the top, we still have the same 1 and 10. 29. Okay, that's not where we should print it. Where should we print it? At the very end of the loop, which gets us something like this, right? After 1 year, you've got 9.76. Then all the way down at the bottom, after 29 years, you now have less than half the original mass, which kind of agrees with our half-life over here, right? It's almost 29 years. After 29 years, it would certainly be strictly less than half, okay? All good? All right. Make sure that you're fixing it. What else would you need to make this turn inable, right? You would need author documentation. So what is this? Author, date. We did this on the 25th, the 5th, February 5th. And then purpose. Computes an isotope decay table for any radioactive isotope. All right, there we go. That's all you need is a short description. What else would you need to do to make sure that you got full points? Get rid of that cruft, which I'll leave in for now when I post this. Now, we're going to be transitioning into object-oriented programming. This is how you would do it in C. This is probably also how you would end up doing it in Python. This is not object-oriented programming. We're going to change this program to not change its behavior. It's still going to produce this table, but we're going to change it so that it's more object-oriented. Right? The object in question here is our isotope and its mass. I've got a name. I've got a half-life. I've got an initial mass. 3 pieces of data. What does that tell you you should be doing? Creating a class to wrap it up into one thing. Not only that, but that class is now going to have more than what we had with books. Books, this is just a bunch of data, right? It's a bunch of getter functions and a toString method and hash code and equals and et cetera, right? But at the end of the day, it's just a bunch of data. It's not the other part of object-oriented programming, which is called behavior, right? And I'll demonstrate that starting on Friday. Then on Monday, we're going to have some guests come in because on Monday after your first assignment is due, then you're going to start working on your project. As part of that, remember you have this thing called a design document that is going to be due not this Friday, but the next Friday. And so I'm going to bring in some folks from the Writing Center, the UNL Writing Center, and we're going to talk about technical writing and how you should go about designing that technical document, that technical design document. That's on Monday though, right? So no code on Monday. Right? I'll see you then.